Welcome back, guys. Welcome to my channel. My name is Bailey Davis. I'm a mathematician. Today we're going to be focusing on 6.2, substitution, business calculus. It's going to be fun. It's going to be easy, guys. After the video, if you could just like it, thumbs up, and leave a comment, guys. Thank you. All right, let's do it, guys. Big ol' integral. Obviously, I want to do just a simple problem. What we got here is, So we're going to start off with this basic integral, guys, and then we're going to see, how we can evaluate it using substitution. All right, guys, so this looks pretty messy, so we're going to rewrite it in a better form. Shout out Brad Carson, camera. So this is just we're just gonna flip forms here, and we're gonna do x times x squared plus 2, and we're gonna raise that all to the negative 1.2, and then tag along our little guy dx there. So this is gonna be a lot easier to work with, so keep this formula in mind, and then we'll take you to the next step. So same equation here, and then what we're gonna do, so since we flipped it into power form, we're gonna find u, and we're gonna try to find like the easiest derivative to use. So we picked x squared plus 2, and so then the derivative with respect to dx is gonna be 2x. Then we want to isolate that dx. So since du's in the numerator, we're gonna bring that over, and this is actually gonna look something like this: 1 over 2x du. And then, so since we have all these parts, we're going to go ahead and use our original equation, plug those in, substitute, and then we're going to find the integral. So guys, we're going to use, all we found is like in terms of u. So now we're going to actually substitute that. So we're going to have our original equation right here. So this is just dropping down. Instead of the x squared plus 2, see right there, it's u. So now we're going to just use u instead of that x squared plus 2. And then remember, this all tags along on the end here. So you'll be able to see it in 1 second. Is that half 2x du. And so then this right here is going to take us to, we're just going to use this. It's going to be half of the integral of x u negative 1.2. And then du's are still our buddy, so he's hanging on there. And now let's evaluate the integral. All right, guys, so since we have this into our u integral form, we're just going to go ahead and evaluate it. So since the half is on the outside of the integral, that's going to tag along. So we have 1/2, integral sign's gone. We're going to drop that x. We got u to the negative 0.2 divided by negative 0.2 plus our constant. And now the last step is going to be to resubstitute our u's so that we can get the equation in forms of x. All right, guys, let's put this thing into forms of x. All right, so we're just going to bring this over here, reintegrate our x. So we have our original equation. I'll write that right here. It was the integral of x over x squared plus 2 to the negative 1.2. So then this right here, we're going to get this form back into x using our u's right here, and this is and then we're gonna also substitute our half. So we have something looking like this. We got negative over 0.4. So we have negative 1 over 0.4, and then that 0.4 is also gonna have our original u. So let's just do x plus x squared plus 2 to the 0.2 plus c. And that's our u substitute. All right, guys, I'm going to make this a little more clear, just in case you're a little lost here. So this is still our original equation. Now, we just simplified it down to make it look a little better. And with this u substitution, pretty much when you're going to use it, if you need to find the derivative of some equation, and you have to use the chain rule, then you're going to have to use u substitution to find the antiderivative. So that's why we're going to use it. And I don't know, I'll explain it a little better right here, so just bear with me. All right, so with u substitution, we have our original equation. We got it down to an easier one right there. And so we're going to try to find the easiest parts of the equation that we can use to define u. And then we can use our power rules and find derivatives. And then we put x in terms of u, so that when we resubstitute, then we can successfully do the integral. So let me show you. So we'll just set up like a table. We'll have u, oh, I'm sorry, my marker sucks. Okay, u, and then we'll have du, dx, which we're eventually going to put in forms of, we want it in du. So that when we put, dx into the formula, it's in forms of u with a du. So for the u in this equation, now that I got it looking all nice, I'm going to use this guy right here. So it's looking like u is going to be x squared plus 2. And then du dx, we're going to find the derivative of u with respect to x. So that's going to look something like this, right? Just using our basic power rule, taking that down right here, and then we're going to actually, get this in forms of dx. But since it's on the bottom, we're going to have to do some flippity flops here. So this is actually going to be like this. dx is going to equal 1 over 2x du. So now that we have these parts, go back, use this equation. We have the integral of x, u, we're putting u in there, to the negative 1.2. And then we also have our little dx over here. So that, what is that? 1 over 2 x du. And we're ready to integrate. Okay, guys? All right, guys, so we're just going to do this easy. So we're going to take the half out because it's a constant. So it's just going to tag along for the ride. So we're going to do half the integral of this. So x, u to the negative 1.2 du. And then, guys, we're ready to just plug those u's back in the original equation, integrate, and then you're done with the problem. Alright, guys, so that's u substitution in a nutshell. If this video was helpful, drop a comment in the comment section below. I really enjoyed teaching you guys today. Like always, just keep learning, and u substitution is awesome.